Greetings, my dear listeners. Since time immemorial, humans have lifted their eyes to the sky and asked, could we live out there among the stars? And if so, how? Today we will talk about terraforming, humanity's dream of transforming planets like Mars or Venus into worlds suitable for life. It sounds like science fiction, yet the further our science advances, the more seriously it becomes a matter of research. Why does terraforming ignite the imagination so powerfully? Because it embodies several of our deepest desires. The desire to survive, even if Earth one day ceases to be safe. The desire to expand boundaries and create new homes for future generations. And the desire to leave a mark on history. For transforming an entire planet would be the grandest project humanity has ever attempted. Picture yourself standing on the shores of Mars. Today it is a dusty desert with a thin atmosphere and bone-chilling cold. But imagine one day, winds filled with oxygen sweep across the valleys, rivers roar through the canyons, and green landscapes stretch beneath a warmer sun. Or Venus, now a blazing inferno with temperatures near 500 degrees and an atmosphere crushing with dozens of Earth's pressures. Yet one day its skies might turn blue, its surface walkable without a suit. Does that not feel like a miracle? Yet behind miracles lies science. And here is the truth. Terraforming is not a single act, not one project. It is dozens, perhaps hundreds of steps, combining physics, chemistry, biology, engineering, and philosophy. Terraforming is not just about reshaping a planet. It is also about reshaping ourselves, learning to think in scales vast enough to encompass worlds. It is fascinating that the dream of other worlds was born long before humanity launched its first satellite. In ancient myths, we already find images of other realms where gods or people lived. In the Renaissance, thinkers like Giordano Bruno insisted that stars are suns like ours, and that they might host their own planets with life. 19th and 20th century science fiction amplified these ideas. Writers described domed cities on Mars, oceans of Venus, lush jungles beneath alien suns. Even if exaggerated, these stories prepared us for a serious discussion of terraforming. Modern science tells us that Mars and Venus, in their current states, are hostile to us, but that does not mean they are forever doomed. The human mind searches for ways to change them, and even if we are still far from real terraforming technology, framing the question itself forces us to think on planetary scales. Is that not inspiring? The philosophical question is simple. Why do we need this? We already have Earth. Would it not be better to care for our planet rather than attempt to rework others? But these tasks are not in conflict. On the contrary, they are connected. To learn to preserve Earth, we must understand how life works under cosmic conditions. And to master other worlds, we must learn responsibility for our own. In a sense, we have already begun terraforming, right here on Earth. For centuries, humanity has altered the climate, landscapes, and ecosystems of our planet, sometimes for better, more often for worse. But the fact remains, we already possess the ability to influence a planet. The question is whether we will use that power wisely. Terraforming is not only science, but a mirror of our imagination. It tells us how far the human mind can reach, and how bold our visions may become. In this first chapter, we only open the door to this great story. In the coming parts, we will trace its roots, the myths, the first ideas, the scientific calculations and projects that may one day turn barren worlds into fertile ones. And so I leave you with a question. If you had the chance to choose which world should first become humanity's new home, Mars or Venus, which would you prefer? And why? Perhaps your answer reveals not only what kind of planet you dream of, but what values you hold most dear. If our first encounter with terraforming was a meeting with the dream itself, then now it is time to ask, how did this dream begin? The history of terraforming is not only scientific, it is a cultural story, woven from myth, literature, art, and the first cautious steps of science, The idea of turning hostile worlds into habitable ones appeared long before humanity sent its first satellite into orbit. As early as the 19th century, writers and thinkers painted pictures of other planets as humanity's future homes. Jules Verne, H.G. Wells, Alexei Tolstoy, their works were filled with visions of interplanetary travel and new worlds. Their portrayals were far from accurate. Mars seemed a place of vast canals, Venus a warm, wet, nearly paradisal world. But these fantasies were crucial. For a long time, the thought of reshaping another planet remained purely artistic. But in the first half of the 20th century, scientists began to speak of it seriously. In the 1930s, the term terraforming entered use, coined to mean making a planet more Earth-like. From that moment, the idea gained a scientific edge. Even if technology was still absent, the possibility of planetary engineering became a subject of real discussion. By the mid-20th century, interest only grew. The first scientific papers appeared suggesting specific methods, creating a greenhouse effect on Mars with powerful gases, or using orbital mirrors to alter Venus. Researchers were no longer speaking of fantasy, but of physics, chemistry, and energy balances. Slowly, terraforming crossed the border from dream to hypothesis. Meanwhile, culture flourished. Science fiction of the 1950s through the 1970s was filled with terraformed planets. In novels and films, people reshaped barren deserts into gardens or turned oceans into new cradles of life. These visions inspired both engineers and readers. Literature often runs ahead of science, opening a mental space for discoveries to follow. But we must remember, the history of terraforming is not only about technical schemes, it is also about philosophy. Each generation interpreted the meaning of other worlds differently. For some, it was a matter of survival, a refuge from catastrophe on Earth. For others, a challenge, a trial of will and intellect. For still others, simply the natural next step of a civilization expanding outward. If we think carefully, the very idea of terraforming reflects a deep trait of humanity: dissatisfaction with limits. We have always sought to go further, beyond the horizon, across the ocean, past the sky. Terraforming is the continuation of that impulse. It is not merely acceptance of the world as it is, but the will to transform it. Today, when we think of terraforming, we stand on the shoulders of those who dared to dream first. Their visions were naive, but they opened the path. They gave us the language, the concepts, the courage. Without Jules Verne, without Wells, without the dreamers of Martian canals and Venusian jungles, there would be no modern terraforming studies. All great ventures begin in imagination. Philosophically, this teaches us that imagination is not idle play. It is a real force, moving humanity forward. The history of terraforming is the story of how dreams become calculations, how fantasy becomes blueprint. And it is this link between art and science that makes the tale so inspiring. In this second chapter, we see that terraforming did not begin in laboratories or on launch pads, but in the minds of dreamers. And perhaps that is the most important lesson. Before you can change a planet, you must be able to imagine it otherwise. In the next part, we will discuss why Mars and Venus became the prime candidates for transformation, and what qualities make them humanity's potential new homes. Today we face a choice. If humanity is to remake new worlds, which planets should come first? Among all the bodies of the solar system, two are most often named, Mars and Venus, and it is no coincidence. They are closest to Earth in size, mass, and composition, yet they could not be more different. One, a frozen desert, the other a furnace. Let us explore why they have become the central candidates in discussions of terraforming. Let us begin with Mars. The red planet has long fascinated astronomers. It is about half the size of Earth, with an atmosphere 100 times thinner, composed almost entirely of carbon dioxide. The average surface temperature is -60 degrees Celsius. Yet Mars has something precious: accessibility and resources. We know now that beneath its surface lie vast reserves of water ice. Water is the key to everything, to atmosphere, to agriculture, to human survival. If that ice can be tapped, it opens Mars has other advantages. Its day is nearly the same as Earth's, just 40 minutes longer. This means human circadian rhythms could adapt without extreme difficulty. Mars also has seasons, polar caps, even landscapes reminiscent of deserts and canyons on Earth. All of this creates the sense that Mars is closer to being a second Earth than any other planet. Now let us look at Venus. By size and mass it is Earth's near twin, but its conditions are the mirror opposite. The atmosphere is 90 times thicker than Earth's, composed almost entirely of carbon dioxide. Surface temperatures soar to 480 degrees Celsius. The pressure there would crush an unprotected craft in minutes. On top of this, Venus is cloaked in clouds of sulfuric acid. It is in many ways the most hostile planet in the solar system. And yet Venus captivates the imagination. Why? Because hidden within its hell is a possibility. If we could reduce its temperature, strip away its carbon dioxide, and create a stable climate, Venus could become a second Earth. Its gravity is nearly identical to ours, solving many biological challenges. Its dense atmosphere could even be an ally if transformed properly. The philosophical question is this: what is simpler, to warm the cold desert of Mars or to cool the suffocating furnace of Venus? In which trial does humanity see itself stronger? Some argue Mars is our chance because it is almost ready. It only needs a push. Others claim Venus is closer to the ideal, but only if we can master its extremes. Thus, the choice between Mars and Venus is not only technical, but symbolic. It is a choice between cold and heat, between emptiness and excess, between harsh simplicity and deadly complexity. And in that choice we see the power of human imagination. We look at these two worlds and ask, which one can we truly turn into a home? In this third chapter we have seen why Mars and Venus are prime candidates for terraforming. Though both are hostile, each holds potential. And in the chapters ahead, we will explore the steps required to bring these bold visions into reality. When we speak of terraforming Mars, the very first challenge that arises is its atmosphere. Today it is far too thin for humans to survive without suits. Surface pressure is about 1/100th that of Earth's, and nearly the entire atmosphere is carbon dioxide. Oxygen makes up less than 1%. For us, that is lethal. But atmosphere means far more than breathable air. It is also protection from radiation, regulation of temperature, and the presence of climate. The atmosphere is the breath of... Scientists have long calculated that to make Mars even marginally habitable, its atmosphere would need to be thickened at least tenfold. But how could this be done? Several ideas exist, each as audacious as they are imaginative. The first idea is to warm the planet and trigger a powerful greenhouse effect. This could be achieved with gases hundreds of times more effective at trapping heat than carbon dioxide. For example, perfluorocarbons. If manufactured in sufficient quantities, they could slowly heat the surface, vaporize carbon dioxide frozen in the polar caps, and set off a feedback loop of warming. The process might take centuries, but in theory it could yield a dense, warm atmosphere. The second idea is orbital mirrors. Imagine vast reflective structures suspended in Mars' orbit, focusing sunlight onto select regions of the surface. These could melt ice, release gases, and begin a cascade of climate change. Such mirrors are not pure fantasy, but rather a hypothetical engineering challenge of the future. The third idea is nuclear reactors, or even controlled explosions on the surface, to accelerate the release of gases from the soil. It sounds radical, but for a civilization that already commands immense energies, it is not beyond imagination. A fourth concept involves importation. Some researchers suggest redirecting comets or asteroids to collide with Mars, releasing water and gases, boosting the atmospheric mass. This would demand astonishing precision, otherwise the consequences could be catastrophic. Yet the idea reveals that terraforming is not merely planetary, but interplanetary in scale. Even with a thicker atmosphere, the problem of oxygen remains. It could be generated through plants, microbes, or chemical reactions. NASA has already tested this. The MOXIE instrument aboard the Perseverance rover successfully produced small amounts of oxygen from Martian carbon dioxide. This is only a prototype, but it proves the process is possible. Philosophically, the task of creating an atmosphere on Mars resembles the art of breathing. Today, the planet is silent, as if it holds its breath. We dream of breathing life into it, of creating a place where air sustains not only fire and water, but hope itself. Yet a question arises: do we have the right to do this? Perhaps Mars is unique as it is, and by imposing our ambitions we risk erasing its identity. The answers are not simple, but one truth is clear. Without atmosphere, Mars will never be a home. Atmosphere is the first step, the foundation for future climates, rivers, forests, and cities. It is what makes a planet into a living system. In this fourth chapter, we have seen how bold and varied the ideas are. In the chapters ahead, we will examine them in more detail and also turn to the question of water, for without it, no atmosphere can make a world truly habitable. When speaking of terraforming Mars, the next step after atmosphere is inevitably water. Water is not merely a chemical compound H2O, it is the foundation of life, the medium in which Earth's biosphere was born. It drives climate, shapes landscapes, nourishes plants, and sustains every living organism. If we dream of Mars as a new home for humanity, then without water it is impossible. Mars has long shown us that it was once different. In the 19th century, astronomers saw dark streaks on its surface and imagined canals. Today we know they were optical illusions, but modern spacecraft, orbiters and rovers, have proven that billions of years ago, Mars truly had rivers, lakes, and perhaps even oceans. Traces of channels, deltas, and water-formed minerals preserve the memory of a wet planet. Today, water on Mars exists in two forms, ice and vapor. Beneath the surface lie vast frozen reservoirs. In the polar caps, kilometers of frozen water and carbon dioxide are stored. Occasionally, spacecraft even detect seasonal seepage of liquid water down slopes, though at current pressures it quickly evaporates or refreezes. All of this tells us water is present but trapped by the harsh climate. How might it be used for terraforming? The first idea is obvious: melt the ice. If we can heat the planet by greenhouse gases, orbital mirrors, or reactors, ice will sublimate, adding moisture to the atmosphere. This could trigger a water cycle, evaporation, clouds, precipitation. Rain and snow might fall on Mars again, accelerating warming and altering the soil chemistry. A second idea is drilling to extract subsurface water. This could support early colonies. But on a planetary scale, the goal is not just extraction, but restoration of a water cycle. We must give Mars rivers, lakes, and oceans again, not simply wells. There are also radical suggestions, redirecting icy asteroids or comets to collide with Mars. Such impacts could deliver millions of tons of water and shift the balance at once, but they require colossal energies and precision. A miscalculation could mean disaster. Philosophically, water is the memory of a planet. It holds the history of Mars, its past as a potentially habitable world. To bring water back to its channels, to restart rivers and lakes, is like awakening that memory, calling the planet back to life. Water is not only a resource, but a symbol. Where water flows, life may follow. But there is another side. If we interfere, we alter Mars' natural history. Perhaps within its ice are microbes, ancient forms awaiting discovery. Do we have the right to melt it before we know? Could we destroy what we most seek? Still, water remains the key. Without it, no terraforming is possible. It is essential for atmosphere, for climate, for biology. It is the foundation of future forests, lakes, and seas. And so, when we think of Mars's future, we first think of its water. In this 5th chapter, we see that water on Mars is both a challenge and a hope. Locked in ice and buried underground, it waits to be released. And in the chapters ahead, we will look at other problems, such as radiation and magnetic shielding, without which neither air nor water can make Mars truly safe. When we speak of terraforming Mars, we must remember, even if we create atmosphere and water, one more threat remains, less visible, yet far more insidious. That threat is radiation. On Earth, we rarely think about it, because our world is protected by a magnetic field and a thick atmosphere. But Mars is a planet without a shield. Its magnetosphere vanished billions of years ago, and now its surface is exposed to cosmic rays and the solar wind. What does this mean for humans? Radiation levels on Mars are several times higher than safe limits. Long-term exposure damages DNA, increases cancer risk, and weakens the immune system. For technology, too, radiation is destructive. Electronics degrade quickly, materials age and crack. Altogether, Mars becomes a dangerous place for sustained life. What solutions have scientists proposed? The first and most obvious is to go underground. In Martian lava tubes formed millions of years ago, colonies could be built. Layers of rock would provide natural shielding from radiation. This is taken seriously today. Orbital imagery has revealed cave systems that might one day shelter settlers. A second idea is domes and shields. Imagine vast transparent structures covering cities, their walls embedded with materials that absorb or deflect radiation. An engineering challenge, yes, but realistic. Such domes could create local oases of life without fully transforming the planet. The third idea is bolder still, to create an artificial magnetic field. Proposals include placing powerful electromagnets or plasma generators in Mars' orbit to simulate a protective shield. It sounds like science fiction, but such projects are discussed in research papers. In fact, in 2017, NASA presented a concept of a magnetic umbrella at a Lagrange point to shield Mars from solar wind. But here a philosophical question emerges. If Mars once lost its magnetic field, does that mean nature itself abandoned the planet? Do we have the right to return a shield it no longer has? Or is this our mission, to continue what ended billions of years ago? Radiation reminds us that terraforming is not just about climate and water. It is about protecting life in its deepest sense. We are not merely building homes. We are forging a shield for an entire world. And this shield would not be natural, but artificial, born of reason. Perhaps this is the essence of terraforming, to prove that humanity can not only destroy, but also create new protections. In this 6th chapter we have seen, radiation is one of the greatest challenges to a Martian future. It demands daring solutions from underground cities to magnetic shields. In the chapters ahead, we will turn our eyes to Venus, where the problems are the opposite, not cold and exposure, but heat and suffocation. Yet there too ideas exist. If Mars seems like a frozen desert, Venus is its opposite, a world of unbearable heat. And yet Venus remains the second prime candidate for terraforming. Before discussing methods, let us picture the scene. On Venus, surface temperatures rise to nearly 500 degrees Celsius. Its atmosphere is 90 times denser than Earth's, composed mostly of carbon dioxide. The pressure is so immense that it crushes unprotected probes within minutes. Above, clouds of sulfuric acid shroud the planet in toxic haze. Why then do we even consider Venus? The answer is simple. In size and mass, it is almost Earth's twin. Gravity there is only slightly weaker than ours. If conditions were different, Venus might have been a second Earth. Thus, the idea of terraforming Venus is an attempt to repair the fate of a planet undone by a runaway greenhouse effect. What methods have been proposed? The first, and most frequently discussed, is cooling through giant orbital mirrors. Imagine a fleet of spaceborne shades blocking a portion of sunlight, gradually lowering the planet's temperature. Over centuries, the atmosphere could cool. Carbon dioxide would condense and fall as dry ice, reducing pressure step by step. A second method is chemical binding of carbon dioxide. Scientists propose using specific minerals or even biological processes to lock the gas into solid form. If even part of the atmosphere were sequestered, pressure would drop and the climate would soften. The third method is more radical still, exporting part of Venus's atmosphere into space. This is a colossal task, requiring energies on the scale of stars. But in theory, if humanity masters fusion or space elevator technologies, such projects could become imaginable. There are also gentler ideas. Instead of transforming the surface, we might first inhabit the upper atmosphere, where pressure and temperature resemble Earth's. Vast floating platforms could host cities, serving as the first stage of colonization. Such habitats might become the seeds of a larger terraforming project. Philosophically, Venus is the challenge of the impossible. Can we turn hell into paradise? Can we reshape a planet that rejected life? Some argue it is madness, too many resources, too many centuries. Others reply that this is the essence of humanity, to attempt the impossible until it becomes possible. This 7th chapter shows us Venus is a world of extremes, but it forces us to think in scales of millennia and energies rivaling the sun itself. And perhaps one day, its skies will truly turn blue, its surface ready to welcome human footsteps. When we speak of terraforming, we increasingly encounter terms that once seemed pure fantasy: orbital mirrors, redirected asteroids, greenhouse gases, artificial reactors. These methods sound like something out of Jules Verne's novels or a far future film. Yet today they are discussed in research papers and at conferences. They form the foundation of possible planetary transformation for Mars and Venus. Let us begin with orbital mirrors. Imagine structures kilometers wide, floating in planetary orbit, their purpose to redirect sunlight. On Mars, such mirrors could concentrate energy on the polar caps, warming the ice and releasing carbon dioxide. On Venus, by contrast, mirrors might reflect away part of the sunlight, cooling the surface. In one case, they act as a magnifying glass, in the other as a parasol. Does it sound unbelievable? Certainly. Yet humanity already builds spacecraft, solar sails, and telescopes with enormous mirrors. Technology advances, and one day such constructs may become feasible. Their creation, however, would demand colossal resources and international cooperation. Now let us turn to asteroids and comets. Some researchers suggest using them as tools for resource delivery. An icy comet directed to Mars could, upon impact, release water and gases, thickening the atmosphere. Or, conversely, asteroids could be sent toward Venus to help strip away some of its oppressive air. This idea is even riskier, but it reveals the interplanetary scale of terraforming, a project that involves the entire solar system. The third method is greenhouse gases. On Mars, the proposal is to manufacture them artificially, warming the planet. These might be compounds hundreds of times more potent than carbon dioxide. On Venus, the task is opposite, to remove or sequester gases into minerals. What is fatal for one planet could save another. There is irony here. Terraforming is the art of balance. The fourth method is reactors and energy. Nuclear or even fusion plants could operate on planetary surfaces, creating local pockets of heat or oxygen factories. Imagine hundreds of reactors along Martian canyons, slowly but steadily altering the air, or stations on Venus converting carbon dioxide into solid rock. These projects sound utopian, but humanity has always begun with utopias. Yet every method carries dangers. Orbital mirrors could malfunction or fall. Asteroids could, with the slightest miscalculation, become weapons of mass destruction. Greenhouse gases could trigger runaway effects. Reactors could suffer accidents. And so the philosophical question arises, do we have the right to experiment on entire planets when the stakes are the future of generations? There are no clear answers, but one truth stands. If we attempt terraforming, we must think as a civilization. It cannot be the project of one nation or company. It will test humanity as a species. Can we unify our efforts for the sake of tomorrow, or will division doom even the boldest visions? This 8th chapter shows us terraforming methods are not only feats of engineering, but mirrors of responsibility. Each step is a balance between hope and risk. And in the chapters ahead, we will see that beyond technology lies another path, biology. For life itself may be the greatest tool of transformation. Until now, we have spoken of mirrors, reactors, asteroids, and other feats of engineering. But humanity holds another tool for terraforming, perhaps the most powerful of all. That tool is life itself, for life reshapes planets. We see this in Earth's own history. Billions of years ago, its atmosphere was utterly different, but microorganisms gradually filled it with oxygen, built the ozone layer, and made the world hospitable to complex beings. If life once transformed Earth, might it not do so else? Where could it begin? With microbes. Scientists already study so-called extremophiles, organisms that thrive in conditions deadly to most life. Some bacteria endure radiation, acid, or heat of hundreds of degrees. Some archaea feed on carbon dioxide or sulfur. Imagine such organisms, or genetically engineered variants, released onto Mars or Venus, beginning slowly to alter their atmospheres. The next step is plants. Plants absorb carbon dioxide and release oxygen. Of course, they require conditions, light, water, suitable temperatures. But given domes or enclosed ecosystems, plants could serve as oxygen factories. Over time, as climates shift, they might expand beyond the domes and root themselves in the soil. There are even more ambitious visions, the creation of synthetic organisms designed specifically for terraforming. Biologists and engineers are already working on genome editing to craft organisms with precise functions, binding carbon dioxide, producing oxygen, stabilizing soils, retaining moisture. In essence, we may become architects of new forms of life, builders of new planets. The philosophical question here is especially sharp. Do we have the right to create life for our purposes? By releasing organisms onto Mars or Venus, we change those worlds forever. We become not just settlers, but creators. And here lies a paradox. Do we not then play the role of gods to other worlds? On the other hand, life has always been the great agent of change. It turned Earth from a barren rock into a green and blue sphere. Why should it not do the same for Mars? Why not allow it a chance to express itself on Venus? If life is resilient, if it adapts to extremes, then perhaps it is life itself that is the ultimate architect of terraforming. This 9th chapter shows us the biological path is not an add-on to engineering, but its heart. Without living organisms, no atmosphere will stabilize, no oceans will sustain themselves. Life is what completes the process. In the chapters ahead, we will discuss the economic and technological efforts needed to make such projects real and how humanity might unite to achieve them. When we speak of terraforming, we often paint grand visions, orbital mirrors, artificial magnetic fields, oceans once again flowing across Martian valleys. But behind such visions always stands a question. How much will it cost and who will pay? Economics and technology form the true foundation, without which no dream becomes a project. Let us begin with economics.
Any terraforming effort is on a scale far beyond anything humanity has ever attempted. Even the construction of megacities, nuclear plants, or space programs pales beside the idea of reshaping an entire planet. Analysts estimate that the cost could reach trillions, even quadrillions of dollars. For comparison, the total global GDP today is about 100 trillion. Terraforming would require resources equal to centuries of human effort combined. Where could such resources come from? The first path is uniting nations. Already we see examples. The International Space Station was built by dozens of countries. Perhaps terraforming will demand cooperation on an even greater scale. The second path is private corporations. Companies such as SpaceX or Blue Origin already invest billions into spaceflight. In the future, they could become key players in planetary-scale projects. But economics is not only about money. It is also about resources, materials, energy, labor. Terraforming would need billions of tons of metals, fuels, and chemicals. Where to obtain them? Some could come from Earth, but more logically they would be mined in space, from asteroids, from the asteroid belt, from moons. Terraforming is thus directly tied to the future of space industry. Now let us turn to technology. Many ideas of terraforming remain only on paper. Orbital mirrors kilometers wide are still dreams. Redirected asteroids, too. But history teaches, what was fantasy yesterday is reality tomorrow. Once, flight to the moon seemed madness. Today we plan bases on Mars. What matters is to set direction and begin. What technologies will be essential? Above all, energy. We will need new sources, perhaps fusion reactors. Next, robotics and artificial intelligence to manage projects too vast for humans alone. Biotechnology to create organisms that can live and work on alien planets. And of course, transport. Next-generation rockets, orbital stations, even space elevators. The philosophical question here is stark. Are we ready to invest in a future that lies centuries or millennia ahead? Most politicians and corporations think in decades at best. Who will take responsibility for a project whose harvest will be reaped not by us, but by distant descendants? Perhaps this is the test of our maturity as a species. Terraforming is not a project for profit or short-term gain. It is a project for survival, for beauty of vision, for giving our heirs not one but many homeworlds. This 10th chapter shows us economics and technology are not barriers but challenges. They demand new forms of cooperation, new sources of energy, new meanings. And in the chapters ahead, we will turn to ethics and ask, do we even have the right to change other worlds? When we speak of terraforming, we are often drawn into engineering and calculations. We speak of mirrors, reactors, asteroids, microbes. Yet behind all this lies a deeper question. Do we have the right to change other worlds? This question goes beyond science. It touches philosophy, ethics, even spirituality. Picture Mars or Venus as unique planets, each with its own history. Mars holds the memory of ancient rivers. Venus tells the tale of a fate that warns Earth of runaway greenhouse effects. And here we come, humans declaring, "We will change you. We will make you like ourselves." Is this not arrogance? Are we not repeating the mistakes we already made on Earth where we altered climate and ecosystems? There is an argument for, if Mars or Venus hosts no life, then we harm no one. Empty planets may serve as our new homes. Moreover, humanity must think of survival. If Earth faces catastrophe, we will need backup worlds. In this view, terraforming is not luxury but necessity. Yet there is also an argument against. We cannot be certain there is no life. Perhaps microbes sleep deep in Martian soil. Perhaps strange airborne forms exist in Venus's clouds beyond our detection. By transforming these worlds, we erase their uniqueness and possibly the only examples of alien life in the universe. Philosophers remind us, life is not only what is useful to humans, it holds value in itself. Even microscopic organisms are part of cosmic history. Do we have the right to tear out that page and rewrite it in our own script?
On the other hand, one might argue that humans are part of the universe's evolution. We are not intruders in space. We are children of the same matter as stars and planets. If we can change worlds, perhaps this is a natural step of development. Perhaps the universe, through us, is experimenting with new forms. The ethics of terraforming is also a question about ourselves. If we plan to alter planets, will we at the same time learn to care for Earth? Will terraforming become an excuse to neglect our home? Or will the experience of reshaping other worlds teach us to value our own even more? Another aspect arises: who will decide? Terraforming is not the project of one person, it is the project of a civilization. But which civilization? Humanity today is divided by borders, nations, corporations. Who will claim the right to alter a planet? Do we have the authority to act on behalf of all living beings? This 11th chapter reminds us, terraforming is not only science and engineering, it is a moral challenge, a question of the boundaries of our rights and of our responsibilities. Perhaps one day we will choose to change worlds. But before that, we must decide what life means to us and what place we occupy in the cosmos. Without such reflection, no technology can grant us the true right to terraform. When we imagine terraforming, we often see it as something far in the future. Thousands of years of work, unimaginable resources, generations of scientists. But let us ask, when might this truly begin? Could the first steps come within our lifetimes? There are several scenarios. The first is cautious. Humanity moves step by step. At first, colonies under domes on Mars, stations in the skies of Venus. Then small climate experiments, local greenhouses, pilot projects producing oxygen and water. Only centuries later would full planetary transformation begin. This scenario matches today's realities best, slow but realistic. The second scenario is accelerated. It depends on breakthroughs. Imagine humanity mastering fusion energy or building artificial intelligences capable of directing planetary projects. Then the pace could rise. Orbital mirrors, atmospheric engineering, these might begin within centuries. This vision is more optimistic, but it relies on revolutionary discoveries. The third scenario is catastrophic. Here, humanity faces crisis on Earth, climatic, ecological, or cosmic. Terraforming becomes not a dream, but survival. Resources are poured in at any cost. It is the riskiest path, but history shows that crises often accelerate progress. It is important to note, terraforming is not one event, but a process. It resembles ocean exploration or city building. First steps appear small, but they accumulate. Colonies on Mars may arrive within decades. Sustainable climate shifts may require centuries. Full planetary transformation may take thousands of years. But in cosmic terms, even thousands are brief. The philosophical question is whether we are ready to think in millennia. Modern people are accustomed to years, decades. But terraforming demands a different scale of patience and vision. It demands work for futures we ourselves will never see. Are we capable of that? On the other hand, humanity has always built beyond one life. Cathedrals rose for centuries. The Great Wall of China took generations. Why not planets? Perhaps terraforming will be the project that unites eras and peoples in one goal. This 12th chapter reminds us, timelines of terraforming are not only about technology, but about thought. We must learn to think on cosmic scales. And then one day, first steps will begin a journey toward new worlds. And so we arrive at the end of our long journey of reflections on terraforming. We have spoken of Mars and its frozen deserts, of Venus and its suffocating furnace, of mirrors and asteroids, of microbes and genetic engineers, of politics and economics, of philosophy and ethics. But above all, we have spoken of humanity. For terraforming is not only about planets, it is about us. Mars beckons with silence and memories of what once was. Venus terrifies and inspires in equal measure. Each of these planets seems to ask us, who are you? Conquerors or creators? Can you act with care toward a world not your own, or will you repeat the mistakes you made with Earth? The answer is not simple. Perhaps the truth is that we will always balance between hunger for power and hunger for beauty, between survival and creation. Terraforming is the symbol of this balance. It shows that within us lies madness to attempt to alter entire worlds, but also wisdom to seek harmony and meaning in doing so. Think of it. We are the only species on Earth capable of imagining other planets and dreaming of making them home. There is something truly great in this. Perhaps this is our role in the universe, not merely to live, but to create new spaces for life. Yet with this comes responsibility. If one day we bring green shoots to Mars or make the air of Venus breathable, we must remember, this is not only our triumph, but our duty. We are not masters of the cosmos. We are part of it, and if we alter something, we must do so in a way that preserves the beauty we encounter. The end of our path is not an answer, but an invitation. Terraforming may become humanity's greatest project, but it must not be escape from Earth. It must be the continuation of our love of life, proof that we can not only take, but also give, to the future, to the cosmos. Picture this. Centuries or millennia from now, gardens rustle beneath Martian domes, floating cities drift in the skies of Venus, and humans look at the stars knowing they are no longer confined to one world. They are children of the cosmos, and their home stretches beyond horizons. In this lies inspiration, hope, meaning. So let our dreams be bold and our hearts wise. If one day we dare to turn deserts into oases and infernal worlds into new homes, let it not be for power but for life, for beauty, for the future, for the cosmos to know. Humanity is not only a destroyer but a creator. And that is why the end of this story must sound inspiring. We stand on the threshold of great achievements, and perhaps the most beautiful chapters of human history are still ahead.